Bismillahirrahmanirrahim. Assalamu alaikum viewers, and welcome to the second part of your transformation of functions graphs, horizontal and vertical shifts. And as we are going to continue from where we stopped in the previous part, that was the part 1. And in this video we are entirely going to deal with the examples relating to the horizontal and vertical shift, or horizontal or vertical transformations of the graphs. Okay, so here let's the very first example of this video you can see over here. Excuse me. You can see here that you are having a log of base, having base Euler number. So this is a natural log. Okay, so you can also write this function y like this. It means the same. Okay, you have to form the graph of this function. For that purpose, you are going to take the reference of your horizontal and vertical shift methodology. For that purpose, you have to assume some f of x here. So let me take the f of x over here. You can see that the basic or the foundation sorry, the foundation of this entire equation, that you can see the foundation function f of x is going to be 3 times ln x. Okay, also you can write as 3 times log of base ex. That means the same thing. Okay, so this is going to be your f of x. If you are bringing change in at this place, it means if you are bringing change in the independent variable, then you are going to perform the horizontal shift. And if you are adding or subtracting anything from this function, you're going to perform a vertical shift. Okay, so if I replace this x by x plus 2, okay, I have just changed my independent variable from x to x plus 2. Now the format of, or the definition of this function is going to be this. Okay, so here if you just take the reference of the general format of your horizontal shift, like if your f of x has been transformed in this form, sorry, I forgot to write my general form c here. This is c. Okay, let me correct. F of x has been transformed to this. Okay, oh, once again, this is your c, as we discussed in the previous video. Okay, so you can see if you compare these two references, you can see that your c is your 2 and 2 is greater than 0. So in horizontal shift, if the value of c is greater than 0, if it is positive, then you are going to shift your original graph f of x towards your left side, c units towards your left. Okay, so your horizontal shift will be 2 units, or c units. C is 2 here, so horizontal shift will be 2 units towards left. Okay, this is it. Okay, and if in the same function f of x, if you are adding something, if we subtract or add something over here, so if I just transform my f of x in this way, that I subtract 1 from this function, now you can compare this with the general form of your vertical shift, which is this. Okay, so here your c is -1, which is less than 0. So the vertical shift is going to be performed 1 unit downwards. Okay, if the value of c is negative in your vertical shift, then the transformation is going to be done downwards. Okay, the vertical shift will be 1 unit downward. Okay, that's what we are going to do. So now our new origin is going to be towards left 1 unit downward from the original origin, okay, from the initial origin. Let us draw the graph of your f of x, which is this. Okay, first of all we are going to draw the graph of this function, and then we are going to perform the transformation on the basis of this explanation. Okay, this and this. So let's go ahead. So this is the expected graph of your f of x 3 times ln x. Okay, so this is it, and this is said to be your original your initial origin. Okay, now you have to switch this origin with respect to the horizontal and vertical shift. So in horizontal shift you have to move 2 units towards left from the original point, which is said to be which is represented by this O. You can see here 0, I must say. So 2 units towards left, this is it, and then in vertical shift you are going 1 unit downwards, so 2 units left from the original origin, and 1 unit downwards. This is going to be your point. Okay, 2 units left, 1 unit downwards. So this is now your new origin. So your original origin or initial origin has been switched with respect to the horizontal and vertical shift, and now the new position of this point is now this. On this basis we are going to assign the new frame of reference or new set of axes, new coordinate plane system. Okay, let us draw this thing. Okay, now the new reference axes I've just drawn on the basis of this new origin point. Okay, so that has been so obtained by shifting this point 2 units left and 1 unit downwards. This is my new origin. I've just represented it with my O dash or 0 prime, we just call it. So now in this with respect to this new set of axes, a new frame of reference, a new coordinate plane, I have to draw the same figure. Okay, so the same graph I have to sketch, and it's going to represent the graph of this equation. Okay, so you can see that over here, once when I was moving my curve at point x power at x equals to 1, my y was 0. Okay, so I have to shift my curve exactly on this format, on this frame of reference as well, in such a way that at x1 my y should be 0. Okay, so let us now draw this thing. Something like this. Okay, this is my 2, and with respect to this 2, the corresponding y is somewhere here, somewhere here. It's right below 3. Okay, it's somewhere here. So it's a little bit messed up here, but I hope you can understand that. Something like this. So this is the graph of this function. Okay, let us authenticate this transformation through the graphic calculator. So let's move over there. This is the graph of my 3 times ln x. You can see just this. And once when I'm going to draw my graph 3 times ln x plus 2 minus 1, let's see how it looks like. Okay, let me remove this thing. Okay, now I'm going to plot my equation here. Okay, it's going to be 3 Okay, this is the format. I think that it's not getting focused properly, but I hope you've understood that I have just written here the equation mentioned in the question out there. So now you can see this is the graph. Okay, this is the graph, and we have obtained exactly the same thing by just obtaining the new frame of reference. We just assign the graph the new curve, which was this, and it was almost similar to the previous one. So that's all. I mean, this question has been handled exactly according to the horizontal and vertical shift. So it has been properly tackled. So it is now confirmed through the graphic calculator. Now let's move ahead to the new example. Okay, so here you go. Another example. You have to form the graph of this function with respect to horizontal and vertical shift. So over here, what you should take as your f of x over where you are going to perform your horizontal and vertical shift concept. So here, if you focus, something is getting subtracted within x, and from this thing you are adding something. Okay, so I'm going to take my f of x as 4x squared. All right, let's move ahead to the horizontal shift concept. If I just transform my f of x into f of x minus 2, okay, so you can see that your f of x minus 2 is now going to be this thing. So wherever you find your x, you're going to replace it with your x minus 2. So this is something, once when you compare this thing with your general form, you can see that your c is minus 2 here. It is less than 0. So horizontal shift will be 2 units towards right. Okay, now in the same way you are going to add 1 in this f of x once you are transforming this f of x by adding 1 in it. So in this way you can see here that your 4x squared has been transformed into 4x squared plus 1. So once when you compare this form with your general vertical shift definition, you can see that your c is 1 here, which is greater than 0. So your vertical shift will be 1 unit upwards. Okay, this is something we have discussed already in the previous video. So this is how you're going to perform the shift. Now what we have to do, we have to draw initially the graph of this function on the 2D coordinate system. Let us draw. So this is the graph of your f of x equals to 4x squared. You can either do it by forming a table, taking a couple of readings over there, and also you can use your graphic calculator and can get the idea of how the curve looks like for this equation, for this function. Okay, so now in the next step we have to assign the new origin. So the new origin will be 2 units towards right from the initial origin and 1 unit upwards. So 2 units right from the initial point and 1 unit upward is going to be somewhere here. Okay, this is our new origin point. All right, this is it. So now over here we are going to assign a new frame of reference, okay, or a new set of axes. All right, so there you go, the new frame of reference, new set of axes having the origin 2 units right, 1 unit upward from the previous one. Okay, but this is a new set of axes. You can see on this basis you have to draw the same sketch, maintaining the same distance and same coordinate adjustments. So let's see now. You see that once when you substitute x1 in this equation, you are having y equals to 5. You can do it by yourself. Okay, so in this basis, I'm going to draw the same curve on this reference axis. So let's see how it looks like. Like this. So this is the curve of this function. Alright, so that's how we perform the horizontal and vertical shift. Now let us confirm our graph through graphic calculator. You can see that this graph is of just 4x squared, and the second graph, this is small v, the small parabola, this is the graph of your equation mentioned in the question, 4 times x minus 2 whole square plus 1. You can see the equations are mentioned over here. Okay, this is the previous one, the first graph, which is representing this parabola, and the second graph is representing this function, which is this parabola. And we were right, our work is right in that sense. Now it is confirmed. So now let's move ahead and see the other example. Okay, here you go, the third example here. Over here you have to make some prudent adjustment before performing horizontal and vertical shift and assigning your f of x. You see you are having 1 minus x power on your Euler number. How about if I adjust it like this? If I adjust it like this, like if I take my negative sign common outside, then it looks like this: x minus 1 plus 1. Now this makes sense. Now you are able to assign your f of x. Here your f of x is going to be negative 0.5. Also you can write half x power minus x. Alright, this is going to be your exponential, this is going to be your f of x, and on this basis you're going to perform your horizontal and vertical shift. Okay, so if your f of x is transformed to f of x minus 1, then this function is going to be expressed like this. Yeah. Now you're going to compare this shift with your general form. You can see that your c is minus 1 here, which is less than 0. So your horizontal shift will be 1 unit towards right. Okay. Now in the same way, if you are adding something in your f of x, you're performing such kind of transformation, this, then in that case your negative 0.5 e power minus x has been transformed in this form. Okay, and once when you compare this transformation with your general form, you can see that your C is 1, which is greater than 0. So your vertical shift is going to be 1 unit upward, okay? So your vertical shift will be 1 unit upward, okay? So now let us assign the graph of this f of x. Okay, let's see how it looks like. After that, we are going to shift our origin on the basis of this transformation. All right, so here you go, the graph of your f of x that we have assigned in the beginning over here. This is the graph of, or this is the curve of this function. Now we are going to switch our origin with respect to this decision that we have just made over here. 1 unit right, 1 unit upward. So over here, 1 unit right and 1 unit upward. Over here, you're going to have your new origin and you are going to assign your new frame of reference or frame of axis. Okay, so let us draw. Okay, here you go. I've just assigned a new coordinate system here. Now we are going to assign, or we are going to sketch the same curve with respect to this new frame of reference. So there you go. Okay, you see I have just assigned the same process how we have sketched this curve. You can see here that from 5 to 2 this curve was right overlapping on the x-axis. I did the same over here. From 5 to 2 this curve is overlapping your new x-axis. Then over here you can see that when my x was 1, then my y value was right below. I mean, it might be 0.25, negative 0.25 or something. I did the same over here. When my x was 0 over here, my y value was negative 0.5. So when my x is 0 over here, my y is negative 0.5. So that's how I have maintained my coordinates, by following the initial curve pattern. And I just draw my new curve. But this curve is representing this function. Okay, so that's how you perform the horizontal and vertical shift. I hope the concept is somewhat clear to you in your mind. You try to do a wide range of questions related to this topic. Practice as much as you can, exercise well, and just firm your grip on this topic as much as you can. So more you saturate yourself, more you get satisfied, and more you become very much enriched and good enough and full-fledged to move forward for the advanced studies related to the same calculus and so on. So that's all for today. And if you find this video helpful, I humbly request to subscribe my channel and just hit on the like, thumbs up, and share this video as much as you can with the other learners and your friends, so that they're also going to be helped. So take good care of yourself, study well, score good, and be happy. Allah Hafiz.